and welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. I'm Mike Maynard, and today I'm finding out why Microchip is Industrial Ethernet. I'm joined by Matthias Karcher. Matthias is the Associate Director of Marketing, Wired Networking at Microchip. Welcome to the podcast, Matthias.
Hello, everybody.
It's great to have you on, Matthias. So we always like to start out by finding out a little bit about your role at Microchip. So can you tell us a little bit about your job at Microchip and what you're responsible for?
Sure. I'm in charge of Industrial Ethernet in our networking and connectivity business unit. And together with my team, we are investigating the markets where Industrial Ethernet is used and deployed, discover requirements of our customers. And based on that, we develop product ideas, define new products, execute in our business units those products to real products, so to say. And then when the product is there, we are bringing this to market and develop also the business for those kind of products.
That's really interesting. So can you tell me a bit more about the range of solutions that you offer for Ethernet?
We are covering a bigger scope of technology, so to say. That means we are doing single-pair Ethernet for sure, but also multi-pair Ethernet, which is also known as standard Ethernet. We are covering really all speed rates or better bandwidths of Ethernet solutions from 10 megabits all the way up to multi-gigabit solutions. And we are also working out various products in our portfolio. It means it starts all with PHYs and transceivers for the different Ethernet technologies or speed grades. We are doing bridges, which are bridging Ethernet to other interfaces like SPI interfaces or USB in particular. And we are certainly also have a big portfolio of various switches, so Ethernet switches, which cover really 2 ports up to more than 50 ports in some cases. So we do low port switches as well as higher count switches, which are then managed or even unmanaged. It means sometimes they have even a core inside. And then certainly also bring in various technologies like TSN, for example. This is also in our scope. And this then really goes all the way up through all the Ethernet speed grades up to even PCI Express.
I mean, that's fantastic. It sounds like Microchip is doing an incredible amount in Industrial Ethernet. But I mean, before we dive into some of what you're doing and what Microchip does, I mean, maybe we can step back and just understand, why is it that engineers choose Ethernet? I mean, there's so many communication technologies they can use. Why is Ethernet such a good choice for so many industrial engineers?
Well, Ethernet is not new. It's out there for more than 50 years. I think it started to develop in the 70s already. Huge infrastructure was developed on all levels, which brought Ethernet really into the application, so to say. And what is also a very key factor is that Ethernet is taught on schools, universities, colleges, and so on. So you find also engineers who are understanding Ethernet very, very well. And this certainly also fosters the deployment of Ethernet in many kind of applications out there.
So it's interesting. So it sounds like that there's some familiarity advantage everyone knows, and also maybe some cost advantage with volume. I mean, is that a really good summary of why people are choosing it, or is there anything else?
Yes, certainly, especially when you look into the system cost. Ethernet has quite some advantages. And as mentioned, it's out there for 50 years. And if you look into systems and products, you see already a lot of Ethernet, but not everywhere. So especially if you look into an industrial communications market, there are some surveys from HMS which show that in 2024, roughly 75% of all industrial communication is already based on Ethernet. It's mainly standard Ethernet, which is also known as industrial Ethernet. But there's a little corner where it's not yet applied. And this is when you go to the edges of your networks. That means to the simple actuators, simple sensors, switches, or whatever it is. There, so far, mainly non-Ethernet technologies, something like Modbus, Profinet, CAN, Profibus, CAN, and so on, was deployed. RS485 based solutions as well. Also, with the newest technology, also this corner can be slowly migrate over to Ethernet to get to the so-called all Ethernet system.
And I think that you're talking about single pair Ethernet here. I see a lot of excitement about single pair Ethernet. Can you explain a little bit about how it differs from, your standard commercial Ethernet?
Yes, it's mainly the cable. As the name says, single pair Ethernet comes with a single pair of cables. In other words, unshielded twisted pairs, so very simple, very cheap cables. Versus when you are using standard Ethernet, you have mainly a thicker cable, Cat5, Cat6, whatever, which use then 2 or even 4 cable pairs, depending on the speed rate. And so you immediately see the difference. So that the cable is getting less complex, less expensive, so to say. You have much better bending radiuses and stuff like that. So you can really squeeze it in any corner of your system very, very easily without having any mechanical problems as well. And this is single pair Ethernet. And compared to standard Ethernet, it's only a change on the lower layers of the ISO-OSI model. That means you have 7 layers, and single pair Ethernet only changes layer 0 and layer 1. That means the file chip is a different one because it's a little different to standard Ethernet, and more particularly the connectors and the cables. This is bringing simplicity into the systems and certainly also quite some cost advantages. But the rest, the upper layers, all the software and infrastructure portions you already apply in standard Ethernet can completely 100% carried over to a single pair Ethernet as well.
And that's interesting because obviously you've got all those familiarity advantages and even lower cost. I mean, I think I've also seen some things about how single pairs being designed to make it easier for connecting multiple sensors. I mean, can you talk a little bit about that?
So there's one new technology in the under the single pair Ethernet umbrella, which is called 10BASE-T1S. And this has a very unique capability in the Ethernet world. Because typically, Ethernet is all about star topology and point-to-point links. That means you have a central switch, and from there you go with a point-to-point link either to an edge node or to the next switch, and so on. And so you build up star topology-based systems. 10BASE-T1S, on the other hand side, comes in with a so-called multi-top bus line architecture. So it's very similar to what you know possibly from CAN or from RS485. There you have the big advantage that you can really hook up a certain number of nodes to one port of your Ethernet switch. And this brings in even more simplicity because you have less cabling, you have less connectors, and can really hook up all these simple edge nodes, sensors, actuators, whatever it is, very easily to your central switch or to a zonal switch, whatever it is.
That's really exciting. I think people who are using something like CAN might, recognize they can upgrade in performance and obviously not have the impact of going to full Ethernet. But what about when you need performance? I mean, for example, what about if your sensor's a camera? Can single pair Ethernet cope with higher bandwidth applications?
Sure, it covers the complete range, as mentioned, from 10 megabits all the way up to multi-gigabit already. And single pair Ethernet, by the way, is nothing new. It's out there already for a couple of years, if not a decade. It all started in automotive some 10 years ago, also known as automotive Ethernet. This term is still used, especially in the automotive area. And it started with a 100 megabit link. So it replaced standard Ethernet links, which some car makers used, and brought them to single pair Ethernet and brought in the cost advantages and the simplicity and the bending radius and stuff like that. So it's already there. And over time, it really developed in all directions, so to say. So we have today 10 megabit solutions, 100 megabit, so 100 base T1, 1000 base T1, that means 1 gigabit, and also 2.5, 5, and 10 gigabit solution. And this is all standardized in the IEEE under the 802.3 umbrella. So these are all open standard technologies. And this brings also a huge advantage to the end users and to the markets because you have various suppliers you can choose of. And this certainly brings even more traction and momentum in all markets, so to say. So it's not all automotive in the meantime. So automotive is a big one, but also in many industrial markets, industrial segments, even commercial enterprise and such kind of application. Single phase Ethernet is getting huge traction.
I mean, that's really exciting to see how it's growing. I mean, one of the other questions I wonder, earlier in the series, we had a discussion about power over Ethernet. So can single pair Ethernet actually support PoE?
In principle, yes, but it's not called PoE. It's mainly then called power over data line, because PoE is also, again, standard-based, also under the 802.3, so the AT and BT standards and all that. But it's all linked to standard Ethernet. In single pair Ethernet, you can do pretty much the same. In some cases, it's already part of a standard. In other areas, it's still in development and is getting in the next version. But it's mainly called power over data line. And there you can pretty much do the same to also transmit power on the data line along with the data itself. And so you can then phantom power certain devices. And especially, again, for these dumb, simple sensors, actuators, and things like that, this is a big advantage, because then you do not need a separate power supply for those devices, which are maybe sitting in a bumper of a car or in a corner of a big machine and things like that. So this simplifies, again, a lot of the infrastructure and the architectures in the systems.
I think it's great how you've described all these benefits of single pair Ethernet, Matthias. But I mean, you also make some other products as well. So, for example, EtherCAT. I mean, do you want to talk a little bit about why someone might choose not to use single pair Ethernet and choose, say, EtherCAT?
Well, EtherCAT is a specific technology which is not under the IEEE, so it's more. It's not proprietary. It's a standard kind of thing, but it's mainly used for applications where you need very precise time synchronicity, as well as some deterministic or determinism, so to say. And this is the area where this is used. So, in fact, you see this very often in robotics applications, some kind of medical applications, but also in machines which need to react very, very fast. So the big advantage of EtherCAT is latency, and so it has very low latency, and this time determinism is also there. We also offer products for that. So we have quite some transceivers in our portfolio, which we sell into those kind of applications. Some of the transceivers even have an integrated MCU, so that you can really apply, so to say, a single chip setup or application to this kind of systems.
That's incredible. I mean, it feels like you've got such a broad range of products. I mean, one of the things I'd love to ask you is, when I talk to people on the podcast, I hear a lot about TSS, Total System Solutions. I mean, presumably you're working with some of the other business units to make sure that they integrate really well with your Ethernet solutions. Can you talk a little bit about how you do that, please?
Absolutely. So there you have to a little differentiate on what product of our portfolio we're talking about. When we are talking about PHYs and transceivers in particular, they are typically connected to a microcontroller, a microprocessor, maybe an FPGA, or sometimes even a switch. Switch is more or less in-house in our business unit. So we do also our own TSS. But certainly, we are also well connected with all the microcontroller business units here in Microchip and work together with them. Develop also our products further together, as well as doing joint reference designs, joint demonstrators, app notes, white papers, and things like that, to show the market and the customers and the end user how easy it is to apply various products from us to accomplish a certain challenge in an application.
It sounds so exciting. I mean, I feel I've only just sort of touched the surface of everything that Microchip does on industrial Ethernet, but I know you're really busy, so we need to wrap this up. And one of the things we like to do at the end of our interviews is ask what your best engineering advice would be. So some advice you'd give to an engineer who's maybe looking at communications within an industrial setting.
Yeah. So I mentioned quite some time simplicity. So it gets easier compared to where we are coming from. But this doesn't mean that the implementation of Ethernet, industrial Ethernet, single pair Ethernet is super easy and mistakes cannot happen. So my best advice to engineers out there who are developing Ethernet, industrial Ethernet, single-phase Ethernet applications is to use our plan check service. That means you can really hand in your design or parts of your design, especially around a PHY or a transceiver, but also around a switch to us, and our experts review this design together with you, give you some feedback, some advices, maybe some hints to change here and tweak there and things like that, so that the application in the end works better and more straightforward, so to say. So this is, I think, the best advice I can give here.
I love that. That's great advice. Knowing you've got a good degree of confidence your system's going to work first time.
Yeah.
Matthias, this has been fascinating. As I said, I know there's a lot more we haven't been able to cover in the time. If people listening to the podcast want to keep up to date with Microchip's industrial Ethernet offering or just find out more, what's the best way for them to do that?
Well, visit our website. It's certainly the easiest way to get in contact with us and also see our product portfolio and our product offerings and things like that. So that's pretty easy on www.microchip.com.
That's awesome. Thank you so much for your time, Matthias. It's been, fascinating learning why Microchip is industrial Ethernet. Thank you for being on the podcast.
Yeah, thank you for all your questions and a good podcast. Thanks a lot.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.